So chapter 6, the numerical structure. This chapter really seeks to help us understand how the number system operates in real life. I was down in Australia with my great friend Tim and Liz Farrell, and Tim had a dream one night. We'd been discussing this very early on in my research, and he bounced out of bed one morning and had this very vivid dream where he produced essentially this figure here, with the 3 and the 6 as the outer boundaries, the 9 running through the middle, and a sort of sine wave running through the middle. And from that, I was able to turn it into this. And essentially, because we know that the 147 group is attached to one string of prime numbers, and the 258 is attached to the other string. And so I've got this sort of sine wave of the prime numbers. And essentially that looks rather like a DNA helix. So essentially we've got a central axis represented by the 0 and 9, the boundaries by the 3 and the 6, and the primes, the 1, 4, 7 and 2, 5, 8. So that accounts for all our numbers in the decimal system. Now, in terms of an apple, the 0, 9 represents the central axis of the apple. The 3 and the 6 determine how fat it is, or its polarity. So that's the magnetic infrastructure, the 0, 9 and the 3 and the 6. And in order to fashion the flesh of the apple, you've got 2 prime number strings, 147 and 258, interacting and swirling around the central axis within the confines of the 3 and 6 to produce the flesh of the apple. And I think that that is the structure of absolutely everything. And essentially you've got 2 opposed spiral vortices creating the torus, which is essentially an interference pattern, a musical donut. So octaves of perception. This was something that was penned by a brilliant chap called Walter Russell, and he wrote that there were 5.5 octaves of the visible spectrum and 3.5 octaves of the invisible spectrum. In other words, there are 5.5 octaves that we can see, and there's 3.5 that we can't, but that we can know about. And so with 12 notes in each octave, you've got 66 notes for the visible and 42 notes for the invisible part of the spectrum. So 108 notes in total. And that number 108 comes in all over the place. For example, 1080 is the mean radius of the moon. 108 square acres is the area occupied by the Vatican City. It's also the number of beads on a rosary, among many and many other things. So we've got these 2 numbers, 5.5 and 3.5. Now 5.5 divided by 3.5 is the same as 11 divided by 7. And 11 divided by 7 gives you 1.571428. And so I'm associating this end of things with electricity. So this 124875, the doubling sequence, we associate that with electricity, with the 147 and 258 number groups controlling the prime numbers. Now, when you look at the reciprocal or the inverse of that relationship, so this time 3.5 over 5.5, you get 7 over 11, which gives you 0.636363 recurring, which is the magnetic polarity of it. And so that's using the 369 group. But so what that told me is that electricity, numerically, it's the inverse or reciprocal of magnetism. So magnetism and electricity, they're essentially the same thing, except one of them's turned inside out relative to the other. And I guess if you know how to flip them, you can flip between magnetic, electric, magnetic, electric. Yeah, so a little more on Walter Russell. Walter Russell, he had something he called the octave wave theory of the chemical elements. And I believe I've done some work in the next section of the book which shows that his thinking is correct. Now, Russell did not believe that there were 81 different stable elements, for example. He said there was only one thing, and that there were different pressure conditions of that one thing that produce these seemingly different things, i.e. calcium, metals, I don't know, all that stuff. So here we can see, for example, at the crossover between the third and the fourth octave, we see hydrogen. And the crossover between the fourth octave and the fifth octave, we see carbon. So he was saying that hydrogen is in octave relationship with carbon. Then the next one up is silicon. Then it's cobalt. And then it's rhodium. So that's a good, nice interpretation of the wave, the octave wave theory of the chemical elements. And he's the only guy to ever have proposed something like that. And I'm certain it's correct.